Good morning, everyone. My name is Walter, and I'm currently a postdoc fellow at University of Copenhagen. I'm originally from Italy, but I spent just a little time in Italy for my education mainly, and then I moved to Hong Kong for my PhD. And I bring basically all the experience related to coral reef in general and the importance of studying coral reef, especially during climate change. So I would like to start with this beautiful illustration and to give you a little introduction about why corals are so important and why we need to take care of corals. So as you can see in the top part, we have a little town, a village, it can be a city, and we have people enjoying the beach life. We have a strong connection of our life living in contact with the ocean and living actually in front of the sea. And we can, for example, spend a lot of time during our holidays, or we can travel, for example. But what is below the water is also extremely important. You see below here, there is another city. This city is made by corals, and it is absolutely incredible how these animals and can support the whole biodiversity under the sea. And we will see how now in the next few minutes. So why corals are so important? Because in general, coral reef, we call them important of high biodiversity hotspot because they are widely distributed from tropics to temperate areas. If you think also about the Mediterranean Sea, we also have corals. And we have an estimated value of like 10 trillion. It's something like an incredible amount of value, economical value. And this value is coming from fishing activities, for example. If you think about fish, seafood, all the protein that we can get from the sea, and especially for population living along the coastline. But also, there is a strong value from tourism activities. Here we see, for example, diving, or even simply if we want to go to enjoy our vacation on the beach, or if you want to have a boat tour. And lastly, it has a strong importance about coastal protection because reef can act to protect the coast from flooding and tidal waves. So what make a coral reef actually? So we always talk about corals. Corals are made by many tiny polyps, which are clones each other, and they live together to form a colony. So this one, for example, is a little polyp, is a single individual, and together they form a large colonies. And the colonies build a reef. And actually, some colonies can even merge together, fuse together to build these underwater cities. And coral reefs together create an incredible ecosystem, a very important ecosystem to provide food and shelter for other organisms. For example, if you think about some invertebrates, if you think about sea urchins, sea stars, octopus. So what make corals to form a coral reef? As I just said, are, we call corals the whole colony, all right? But actually, these teeny round shapes are the single polyps. So these are single animals and they live together to form a colony. Corals are animal, so they are, let's say, the cousins of jellyfish, and they have they live in symbiosis with tiny microalgae, which can support the photosynthesis through the photosynthesis some important food. And these microalgae have some photopigments, which can be fluorescents, and they can form this and they can produce these beautiful colors that we can see here. Now, what looks like healthy reef? This is an healthy reef. This is, of course, we don't see this kind of picture in Mediterranean Sea, but this coming from the tropics. And but simply you can see this very colorful. We have some fish swimming around, and some tiny fish, and clear crystal water. But sometimes we see also this kind of reef, and this is actually a damaged coral reef. And we see, for example, it's more white, color are more dull, and there are little to no animals swimming around. This is a kind of transition between healthy reef and bleaching reef. This is a temporary transition, so it's reversible. But if we don't stop the stress, what is causing the stress to let coral bleach, actually corals will die. So what happened during coral bleaching? As I said before, corals are this symbiosis between animal and algae. So healthy corals has this tiny algae living in symbiosis in the coral tissue. When the corals go under stress, algae start to live. Scientifically, algae start to produce some molecules that can be dangerous for the coral itself. So kind of corals are kicking off this algae. And when they leave that's basically the bare skeleton and becoming completely white. That's why we call bleached corals, because are becoming white. What is causing coral bleaching? The main cause is climate change. We call this climate change is a broad term to define a threat for the whole ecosystem in the world. Climate change is coming from anthropogenic activities, directly from input of CO2 in the atmosphere. CO2 is not the only greenhouse gas. We have also methane, for example, but CO2 is the most abundant. And when we release CO2 in the environment, in the atmosphere, actually this can create like the greenhouse effect, which can make the ocean warmer, eventually lower the oxygen concentration, and even make the ocean more acidic, because the CO2 is linking with the water and can make the water more acidic. The consequences are multiple. Yeah, we have a sea level rising, we have coral bleaching, we have a toxic algae, we have habitat alterations. And these issues are well recognized. But how we can measure the health rate of corals, this is quite important, because we want to know what is the status of corals in this exact moment, if they're healthy or if going on stress. And this was the work from my PhD. I spent a few years in developing this kind of device. And this is called a respirometer. So it's basically an instrument that we can bring on the water, and we can attach directly on the coral surface. And this is me supervising the work. So we applied then these instruments. This was in Hong Kong, where I did my PhD in the last few years. We use this instrument together with other instruments directly underwater to measure several parameters, and in general to measure the health of corals underwater. So here you can see, here I create my underwater playground. I bring some instruments underwater and I measure several things. This is quite different, and I want to point out this a little bit. It's quite different for normal coral studies. Normal coral studies are performed in the laboratory, where we collect corals and we do our experiments, while in this case, we bring instruments underwater. And however,
Two
the
minutes.
information, yes,
Walter.
the information that I have from bringing instruments underwater is still minimal, because I'm still missing some resolution in observing the change in corals. And here comes my Marie Curie project, which started this year. So I want to bring the observation from macro, okay, from the large scale, to micro, to the small scale. And we use, here you can see 3 different corals. These are actually corals from Mediterranean Sea. And you see here a tiny pin, which is called a microsensor. So a small sensor, we can measure the oxygen in the corals. And this is a time lapse. So you can see the corals are alive, and we can measure the oxygen inside the coral. And this can give us an information, an extra information on the health. And actually, the overall objective of this project is to track cellular uptake iron. So we want to measure some how metals can affect the health of corals. But the project just started, so hopefully for the next midnight, I will bring you some results and some new insights. This is the end of the talk, and thank you for your attention.
Thank you very much, Walter. It's clear how our Mediterranean Sea is affected and it can be helped. And do we have any questions from the schools? I'm sure questions will come. Here we have from the school from Croatia, Ms. Natomic. You can ask the question. You're mute. No.
You can.
My question is, how quickly does climate change affect the corals, and how quickly they actually decay, and is it too fast to the point where we can't revert to changes?
This is very good question because climate change is happening at a rate that is too fast for corals, but not only corals, for the whole animals on the earth to adapt. So usually the changes in the climate happen in a very long time scale. Okay, so animals, most of the animals could adapt to the changes. And if you think about, for example, evolutionary changes and cellular changes in the organism, but right now, the climate change in terms of mainly global warming and then ocean warming is happening too fast. And this is creating stress. This is creating temperature stress in the animals. So animals who can, like corals, who cannot escape, cannot swim, are eventually like the destinies to die. Some animals, like fish or some, for example, larger animals, whale or sea turtles, are able to migrate, and so eventually can find some cooler water to survive. But yes, it's happening basically too fast.
Okay.
Sure.
Thank you. We have another question from Crisabella Seriu. If the corals were disappeared from the sea, would it affect the fishes? A question from Larissa.
Absolutely yes, because corals and coral reefs are like these living structures in the sea. So they keep growing, and by growing underwater, they create an habitat. They create shelter. Okay, if you think about like the cities in the middle of the desert, they create shelter for people to live, and the same does the corals, creating shelter for fish or invertebrates because they can, for example, they can reproduce near this area, they can hide from predators. So if coral disappear, we might also lose the fish, and then this can affect our lifestyle as well later on.